The metal to be used for covering a cylinder having external radius 5 cm, height 21 cm and thickness 1 cm is to be cast from a new cylinder. What should be the height of the cylinder of radius 3 cm from which this casting can be done? Alright, so what does this question says? Okay, so let's visualize this question first. Alright, so question is telling me that there is this cylinder. Alright, this is the cylinder and we are given the external radius of the cylinder and height is 21 centimeter. Okay, so let it be for a moment. Now there is again another cylinder. Okay, again there is another cylinder and the radius of the cylinder is given to us as, what should be the height of the cylinder? Radius is given to us as 3 centimeter. Okay, so the radius is 3 centimeter. Let's say height here is h. All right, now the question is saying me that what I'll be doing is I'll take this cylinder and then melt it. Okay, I'll melt this cylinder and whatever metal I'll get, I'll use that metal to cover this cylinder. I'll use this melted metal to cover this cylinder. Okay, just like this. Okay, I'll just draw it. This is the covering of this cylinder and the covering is given to us as, the covering is 1 centimeter thick. This thickness over here is 1 centimeter. All right, so this is the proper visualization of this question. I hope you understood it. Right, now we know that this is the cylinder that is to be melted and then the melted metal is used to cover this cylinder over here. Now we are given that the external radius is 5 centimeters. So that means from the center of the cylinder to the external covering, this is the external radius, which is 5 centimeters and height is given to us as 21 centimeters. So height here is 21 centimeter. All right, and we have to what should be the height of the cylinder? So we have to find out what should be the height of this cylinder over here that is to be melted. All right, so how do we proceed now? So what we'll do is, okay, so first of all, if you use common sense over here, this external covering here, the volume of this external covering of this cylinder, the volume of this external covering of the cylinder should be equal, will be equal to the volume of this cylinder over here, right? This is the common sense because we are melting this cylinder and then covering it with this, covering over this. So that means this the volume of this external covering should be equal to the volume of this cylinder over here that is to be melted. So that means volume of the metal will be equal to, okay, so how do we calculate that volume? Okay, so what we'll do is, in order to calculate that, first of all we'll get the volume of this entire cylinder with covering. Okay, so first of all we'll get the volume of cylinder with covering. Okay, with covering, and then subtract volume of this cylinder without the covering. Okay, that means this inner part. So we'll subtract volume of the cylinder without the covering. Okay, and then whatever the difference will be, we'll get the volume of the metal from that. Okay, so let's calculate now. What is the volume to calculate the cylinder? It is pi r square h. All right, so first let's calculate for the with the covering. Okay, first calculate the volume with covering. So now pi r square. So what is pi? It is 22/7. Now r here is 5 centimeters. So we are talking about with covering. So from center to the covering, the radius is 5 centimeters. So radius r is 5 5s are 25. All right, and h is given to us as 21 centimeters. Now let's talk about volume of without the covering. All right, again the formula is pi r square h. Right, now pi is again 22/7. Now what will be the radius here? So now if I visualize this over here, this is the inner part, this is the inner cylinder, right? And this is the covering over here, this is the covering, and this thickness over here, this thickness is of 1 centimeter, right? So that means if from center to this external covering, the total distance is 5 centimeter and the thickness is 1 centimeter, then what will be the distance of this inner portion, inner cylinder? It will be 5 minus 1, 4 centimeters. So that means this inner is this inner cylinder's radius is 4 centimeters. So let's write it down. So we have the radius here as r, that is 4 centimeters. So 4 4s are 16 and h is again 21 centimeters. Now let's simplify. So we get 7 3s are 21, 7 3s are 21. Now 22 into 3 is 66, and we get 25 minus 16, which will be okay. So I don't know if you understand this. I have taken 22 into 3 common. So 22 into 3 is 66, and we are left with 25 minus 16. So 25 minus 16 is 9. All right. So we have got the volume of the metal, which is 66 into 9. And this volume will be equal to the volume of the cylinder, right? So that means the volume of cylinder here, this cylinder, will be equals to 66 into 9. Now what is the volume of the formula is pi r square h, right? This is equals to 66 into 9. Now pi is pi r square h, right? Now pi is 22 by 7. R is given to us as 3 centimeters. So 3 3s are 9, and h is what we have to find out, right? This is h. So let's simplify. We get 9 9 cancelled. 22 into 3, right? And the 7 will go on the right hand side. So 7 3s are 21. So we have got our required answer. So h is equals to 21. This is our required answer. So here option C is the correct one.